Okay, let's start with episode 3, designing a basic graphical user interface for the subtractive synth. As we have seen in the demonstration, we have used the mawk Werkstatt interface and transformed it into a SuperCollider interface, the mawk Werkstatt-01, which we can see here. And now we are going to do a little walkthrough the code in order to understand how we can actually do this in SuperCollider. Okay, so in order to do the GUI definition, we follow 6 steps. What we have to do is we have to define variables for our controls. We need these variables later in order to access the controls and to manipulate them. For example, if we want to connect our MIDI interface to the graphical user interface. We then define a set of GUI helper functions. These helper functions are basically just helping us to write less code and make the GUI definition a little bit less tedious and cumbersome. Then the next step will be the window setup and the control interface. The window setup is just defining the size and position of the window that we see. And the control interface is not actually part of the synthesizer, but in order to control it, we might have some extra buttons, some virtual buttons outside, for example, in order to start the synthesizer or stop the synthesizer, things like this. We won't talk about this in this code, but later on. Then the next 3 steps, or the next 2 steps, sorry, are the main part of defining the interface for the synthesizer. First of all, we need to draw the background and draw the labels. These are the non-interactive elements of the interface. We need to have text labels written on it. We need to draw some boxes and stuff like that. And then the main part of the functionality of the graphical user interface, in our case, it consists of knobs, buttons, and keys. We need to define them, position them, and then attach callback routines to it. And the last step that we are going to see in our code is meta control and window handling. This is just a thing that you might be adding to your graphical user interfaces in order to make it more usable within SuperCollider, namely to react to certain keystrokes and define what is happening when the window is closing. Okay, the slides actually show the code, and as you can see, you can walk through it, but it's not very readable. So what I'm going to do is I'm going to switch over to the code and show it directly within SuperCollider. So as I said, the first step is going to be the definition of the variables. As you can see, variables always come first in a functional definition, and we simply need to name all our controls. And as you can see, buttons are named buttons, controls or knobs are named controls, and labels are named labels. And so this is what I've done here. And as you can also see, I've got some keys, and I simply named them. So everything that we see on the interface, which is here, like the knobs or buttons or keys, do have a variable here. All right, and we are using these variables to store the elements. Okay, now the next part is the GUI helper function. In order to make the code a little bit more readable, I created a set of helper functions that is configuring and placing a control with just a couple of parameters. And the first one is make control, and by make control I mean make a knob, right? See, and as you can see, the function has 1, 2, 3, 4, 5 parameters. The first one will always be the window, a reference to the window. Px and py is the position on the screen in the window. Size will be the size of the knob, and text will be the text that is going to be placed under the knob. So there's the knob, this is the size, and there's the text. So it combines these 3 things. And as you can see, there's a knob function in SuperCollider. If I'm looking up the documentation with Control D, you will see, okay, there's the definition for it. And so I'm creating a new knob in the window. And in order to place it, I'm going to use a rectangle, and the rectangle specifies the position and the size. All right, so there's a rectangle which is giving us the position and the size. And as you can see, it will be stored in a local variable called C for control. All right. Next will be to set the action, and as you can see, C action underscore, and then I'm going to hand over a functional object, and this functional object gets 1, 2, 3, 4 parameters and allows me to access the value of the knob. So when I'm turning the knob, this anonymous function is going to be called, and basically it's just telling us action function called, value will be displayed. So there's no connection to the synthesizer yet, it's just printing out the value. So, and then I'm going to create a label, and the label is a static text element, and again we're using the window, again we are using the rectangle to position the object, in this case the static text, and the formula that I'm using here is just needed to at least in principle center the text below the control. So, all right, and oops, I'm sorry, and then I'm going to define the background color, the string color, I'm going to define the alignment, which is center, I'm going to define the font, and I'm also giving it the text that is going to be displayed. And as you can see, we make the background transparent, we are centering the text, and making the string color white. So here we've got the visual properties of the static text, which you can design to your needs. Okay? So, and now something very strange happening. I'm just writing C here. What does this mean? Well, in functional programming languages, and we are defining a function here, as you can see, this is the functional block, the value of a function is always the value of the last statement. And the last evaluated statement here is C. In other words, I am returning the knob. Okay? So what I'm returning is the knob of the control. Okay, which can then be stored in one of our variables. Okay, this is how our control is made, and the button is not very much more complex. As you can see, the button function has got 1, 2, 3, 4, 5, 6, 7 parameters, and we are trying to create a button with 2 states, because in our interface we want to press this button, pulse, and then it should switch to saw, and when we press it again, it should switch back to pulse. All right, and as we in the interface only have 2 state buttons, I specifically defined a function for a button with 2 states. It's obviously also possible to have a button with 3, 4, 5, 6, 7 states, but for our needs in our mawk interface, we only got 2. So S1 text is the text for the first state, S2 text is the text for the second state. So as you can see, we are defining an array states, and we are adding two values here, and these values in turn are arrays also. And as you can see, for a state, in order to define, you need the text, you need the color, and you need the background color. All right, so what we have is we've got a text with white button state with white text on gray background, and this is exactly what we see here, white text on gray background. All right, now we are creating a button, and again we are using our rectangle to position the button. Then we are setting the state, which we just have defined. We are setting the action. We've seen that before. It's just the very same thing as we've seen on the label. And then we are defining our label, and again it's a static text. We are also doing the position, clear background, white, centering, font, and the text. So, and now we are returning the button because we want to have the button as a result. So in the make key function, which is trying to create one of these 12 keys here, which we are using for creating one of these 12 keys, is basically the same thing. We're using a button. This time it only has got a single state, and we are defining it here. So there's the text, and then we are adding the states and the function and returning the button. So, and the final helper function, final two helper functions, no, final three helper functions that we have are helper functions for drawing background. We want to draw rectangles here. We want to draw brandings here, text like this, the mawk and Werkstatt, and we want to draw labels like VCO mod, VCO, and VCF. So for these three elements in the interface, I've defined functions, and as you can see, we are using a pen object here. The pen object allows us to draw arbitrary objects. It's basically, well, acting like a pen. Just suppose you have got your canvas and you're just drawing on it, and the pen has multiple options. So you can say the fill color and the stroke color. Again, background colors will be clear and the draw color will be white. And then we are going to draw 1, 2, 3, 4 lines, and eventually we're going to fill it up and draw it out. And these 4 lines, 1, 2, 3, 4 lines, are the 1, 2, 3, 4 lines of the box. So this is basically a rectangle will be drawn here at a position X, position Y, with the width of W and the height of H. So the branding is just static text. We've seen that before, and it's just printing out some static text at a position, and the label is again some static text, and again it is printed out, but the difference is that we've got different sizes here, but actually we don't. What is the actual difference? Text size? There is no difference. Probably it's just a doubling here. Okay, anyway. Right, now the synth that we find here, we will be ignoring it because this is going to be replaced with our real synth. And now the setup of the GUI is starting. So we're closing all the windows just to make sure, and then we are creating a new window. And as you can see, all we have to do is to define the window, define its title. So up here, there's the title. That's the title. And then we are defining its position on the screen. So this is basically the position on the screen. It says 100 pixels from the left, 0 from the top, and the window is going to be 900 pixels wide and 640 pixels high. So we're also defining the background color. In our case, it's black, and then we put the window to the front so it comes up, make it visible. All right, and here we define some buttons that is used for the control interface. As I said, we're not talking about the control interface right now, but we'll delay that to a later moment. So now, in order to draw the background, we need to define the draw function for the window. And so we are basically just setting the draw function for the window. And as you can see, we are drawing one rectangle, set 2, 3, 4, 5, 6, 7, 8. And as you can see here, this is what's happening here. So we're drawing the box for the VCO, for the VCF, for the VCA, VCA mod. So basically, these lines here, the background lines, the box lines, are going to be drawn. And this is done by attaching the draw function to our self-defined functions. The next step is going to be the drawing of the brandings. So first of all, we're drawing the branding, which is control. Obviously, we're drawing this string here. Then the next step will be Werkstatt. And as you can see, we now are calling our helper functions. So drawing branding dot value is calling the draw branding function. And then we are giving the parameters, the window, the position, the text, and the size. And so we can, by this, we can draw Werkstatt, analog synthesizer, mawk, and all the rest of it is going to be drawn. Then we are drawing the labels, and we're using the draw labels helper functions, and this will be this one, this one, this one, and this one. And as you can see, they got a white background and a black color. And eventually, now we're using our functions, our control make control functions, make button functions, and make key functions to define the VCO, frequency control, VCO control, and so on. So by this, we are creating a new control, and then we are storing it to the variables that we've defined beforehand. We don't need to store them. Actually, it would also be working without storing them, but if we don't store them, we can't access them later on. So basically, this is just a precaution to be able to set the function later, for example, with our MIDI keyboard. So these are the lines for defining the knobs, these are the lines for defining the buttons, and these are the lines for defining the keyboards. And the sixth and last step will be here. We are having this meter control. This allows for two things. First of all, we can attach the command dot command to a specific function within our interface. As you can see, what we do is we are, by pressing command dot, we are setting the value of the start button to 0. And in order to be able to use it, we need to use the command period object and add the function to it. In other words, we are registering, we register a callback function, and this is going to be the callback function that is going to be attached to the command dot interface command. Sorry. And finally, we are saying what is happening when the window is closing. So if I'm starting, if I'm starting the stuff, I've got my interface here, and now I can click here in order to close the window. And when I close the window, then this function is going to be called. And as you can see, there's some node to be freed, and the command period function is going to be removed. All right. So far for the small walkthrough through our code. As you can see, it's not really complicated. It's just lots of code, and yes, with a little bit of structuring, it's relatively easy to set up the interface. Okay. Final conclusions. The graphical interface is implemented with a number of components. The components that we've seen here is window, we've seen draw rect, we've saw pen, we saw static text, we saw buttons, we saw states, and we saw knob. And with these elements, we were able to create the interface. As we also have seen, defining helper function does reduce the code length a lot and makes defining the interface more human readable. So we basically can just walk through it and say, okay, this is this button, this button, this button. It's far more understandable. Now that we have got our graphical user interface, we actually have fulfilled important steps toward a usable synthesizer. Only with a graphical user interface or some sort of interface, a synthesizer will be usable. But what we haven't done so far, we didn't connect the graphical user interface to the synth. So in order to connect the graphical user interface to the actual synth definition, you need to define a callback function.